In a survey out of 500 car owners, 100 got quotes from Easy Insurance E, 175 got quotes from Value Insurance V, and 250 got quotes from Winners Insurance W. Some of the car owners did not obtain quotes from any of these insurance companies. We have some more information here about these companies, but we want to draw a Venn diagram to represent the above data. So we're dealing with 500 car owners, so that's our universal set. So there are 500 elements inside this rectangle. We don't show the dots for each element. We would have 500 dots. We just consider the number of elements. So the number of elements in U is 500, and we can show that number in square brackets. So the universal set consists of three sets E, V, and W. E is the set of those car owners that got quotes from Easy Insurance. We can see that there are 100 of them. Similarly here, this set represents the number of car owners out of the 500 that got quotes from V, or Value Insurance. And 250 of the 500 car owners got quotes from W, Winners Insurance. So there are 250 elements inside this circle. Again, we don't list them obviously, we just write the number of elements inside W in square brackets. Now usually when we construct Venn diagrams, we look for the intersection of all three sets first of all. So we go down through this and we see that 25 car owners got quotes from all three insurance companies. So the number of elements in this region here is 25. So we can write 25 in square brackets in here. So there are 25 car owners in here. You can imagine 25 dots with the name of each car owner. So the 25 elements in this region represent 25 of the 500 car owners that got quotes from all three companies, E, V, and W. We are given that 2 car owners got quotes from V and W, but not from E. So this region here must have 2 elements. So this region represents the number of people that got quotes from V and W, but not from E, so they don't belong inside set E. 192 people got a quote from W only, so we have 192 people in this region. Now we can actually complete this set W. 4 regions must sum to 250. So we have 250 minus 192 minus 2 minus 25. We get 31. So there are 31 people in this region. Now, as of yet, we don't have enough information to find these 2 regions. We have 4 regions making up E and we have 4 regions making up V, so we can't complete V yet. But we're given that 75 car owners got quotes from exactly 2 of the above companies. So let's look at the regions that constitute exactly 2 regions. 2 companies. So this is one region, this is another, and here's the third. So elements in here belong to exactly 2 sets only. And we're told that 75 elements belong to exactly 2 sets, not 3 sets. So we've 31 and 2 is 33 elements belonging to exactly 2 sets so far, and we have to take that from 75. 75 minus 33, that's 42. So we have 42 elements in here. Now we can complete E and V. To complete E, we have 100 minus 42 minus 25 minus 31. That's 2. So we have 2 elements out here. And similarly for V, we add these 3 numbers and take the result from 175. Now we have the regions for E, V, and W completed. Now, some car owners may not have got quotes from any of these 3 companies. And it actually says it at the start here, some of them did not obtain quotes from the 3 companies. So, how do we find the number of people that are inside U but outside these three sets? Well, we just sum up all the regions here, get the union, the number of elements in the union of these three sets, and take that value from 500. So, summing the 7 regions, we've 1, 2, 3, 4, 5, 6, 7 regions, we get 400. So we want the number of elements in the set U less the union of E, V and W. So that is 500 minus 400, which is 100. So we have 100 elements out here. So 100 people did not obtain quotes from any of the 3 insurance companies, E, V and W. If a car owner who was surveyed was selected at random, what is the probability that he or she obtained a quote from 1. Easy Insurance or Winners Insurance, that is E or W? So we are randomly selecting an element from 500 elements. We have 500 elements inside set U, the rectangle. So we're dealing with 500 equally likely outcomes. And in a previous video, we saw that to get the probability of any event, we get the number of elements in the event divided by the total number of elements in the sample space, which is 500. So here the event is E or W. So this event consists of the union of the sets E and W. I'm showing the set E union with W in red. So to calculate the probability of the event E union with W, we get the number of elements in E union with W, and to do that we just sum these 6 regions. So we get 294. Another way that we could arrive at this number is to add the number of elements in E, which is 100, onto the number of elements in W, which is 250. And since the elements in the intersection have been counted twice, we subtract out the number of elements in the intersection of E and W. Okay, we get 294 over 500. I've S written here for sample space, but I'm also calling it U. In part 2, we want the probability that a random selection in the survey gives us a car owner that got quotes from E and W. So we're interested in a car owner that got quotes from both companies. Well, that's the intersection of E and W. That's this region here. So we want the probability of E intersecting W. That's the event we're interested in, shown here in blue. So we want the number of elements in it divided by the number of elements in U. Well, we have 31 plus 25, that's 56 elements divided by 500. So again, you have to imagine selecting a point at random from 500 elements inside set U. So what's the probability that we select one of these 56 elements? Well, we just put the number of elements 56 over the total number of elements 500. Every element has the same probability of being selected. The probability of any particular element being selected is actually 1 over 500. Now we want the probability that a person is selected from E and W but not V. Now I will show that in green. E and W would be all of this region here. That's E intersecting W, but we don't want all of it. We only want the part of it that does not involve V. So we just need this part of it. So this is E intersecting W. That's what E and W means. But we need to subtract away from it V. So we would read this as E intersecting W less V. This forward slash means less V. So to get the probability of this event, we put the number of elements in this event, which is 31, over the number of elements in U, which is 500. In part 4, we want the probability that a person is selected from at least one of these 3 insurance companies. Well, here we're interested in the probability of the event consisting of the union of E, V and W. So if a person is randomly selected from the union, that's everything inside this purplish color, then that person got a quote from at least one of the 3 companies. That person got a quote from either E, V or W. And that person could actually have gotten a quote from just E, just V, or just W, or maybe all 3 companies. So that person would be one of 25 people in here, or maybe just from two of the companies. But in any case, if we select a person from the union of the 3 sets, that person will have gotten a quote from at least one of the 3 companies. So how many elements are in the union? Well, we calculated that before. We saw that there were 400 elements in the union and 100 elements outside sets E, V and W. And the total is 500, of course. So we have 400 divided by 500, 4/5, which is 0.8.